And welcome back. Now this week we're going to be talking about this little tiny PCB made for me by JLC PCB, and it is quite small. You'll see how small in a minute. But the point about this, as you can probably just about read there, this contains or will contain an ATMega328PB chip, which is the successor to the ATMega328P. Now, why did I design this PCB? Because, well, it was a mountain there to be climbed in the first place, but I wanted to see whether the additional features of the PB version of this chip, beloved to all in standard, Arduino UNO boards, was really worth it. For example, you get, on this board, you get at least 2 extra pins, possibly 4. You get an extra I2C, you get an extra SPI, and you get an extra USART. So that means you can communicate with other boards or modules or whatever, or even debugging, while still connecting the USB cable and uploading programs and stuff like that without any kind of interference. And the I2C and the SPI is very useful because some modules, would you believe it? I know it's hard to believe, but they do not play nicely together. Either the manufacturers have taken shortcuts, or there's just something funny about the chips or something, but they do not play nicely together. So where you might get 2 modules that are supposed to work on the SPI bus, and you chip enable one and then flip to the other, and it goes, no, I'm not listening to that, for whatever reason. Okay, so having the extra SPI bus or I2C bus could be very useful indeed. And of course, who doesn't need extra pins? Let's face it, the fact you get at least 2, possibly 4, and we'll come on to the details a bit later, could be, make or break for a particular project, isn't it? It could mean the difference between using an UNO type board or moving up to a Mega. So let's have a look at this board then in a little bit more detail, and you'll see exactly how big it is when you see the one behind it. I want to give a shout out to my sponsor JLC PCB, manufacturers of custom PCBs, made simple. One of their new features that's coming up shortly is their SMT assembly process. And their webpage contains a lot of information about what their capabilities are and some various very common facts. If you prepare your PCB using Easy Ide, you'll find that when you place components, you have the option of using their LCSC assembled catalogue. As you can see here, I've just chosen the IC that I'm going to be using in a future project, and it's come up as part of the LCSC assembled list. That means they can pick and place it for you on that board. If you can, try and use their basic list rather than the extended list, which means they'd have to change the components in the pick and place machine. Designing a board could not be easier using Easy Ide. And the fact it links into the JLC PCB website is going to make ordering an assembled SMT PCB an absolute breeze. Why don't you try them out today? So the board you're looking at right now, this one here with all the wires attached, looks a bit more complicated than it really is, believe me. It's just hooked up for a demo a little bit later on, and it's got one of those boards attached to it. Let's describe exactly what it is. Well, first of all, here's the PCB. With the old chip just put on there for show. It's not supposed to be soldered on there or anything. What is supposed to go on there is a little tiny chip like this, which is the surface mount version of the PB. So that gets soldered on there. That's actually not orientated correctly. Pin 1 is top right here. But that goes on there, and then this board plugs into an UNO like that with some standard header pins. It's all pretty simple. Oh, on the back there is room for some decoupling capacitors, because I was worried that because the chip is now physically far removed from where the chip used to be, I think that might be a decoupling capacitor, that might be the crystal, not sure. Anyway, wherever the decoupling capacitors are on here, I was worried that the fact that the chip is now hanging off the end of the board like that, I thought, the last thing we need is instability, so I'll put room on the back for a couple of 100 nanofarad 0603 capacitors, and then that plugs in there using some standard header pins or stackable ones. I've got both versions here. So on this board, which I'm going to try not to disturb too much because I want to show you the demo, I've got some header pins soldered underneath, the chip on there, a couple of capacitors underneath. Yes, I know, all beautifully soldered with my hot air gun, would you believe? It's worked rather well. And nice bit of SMD soldering on the top. Though I say it myself, I do believe I've come quite a long way in the last few months. That was actually soldered using my new ATMEL soldering iron, but with a gull wing soldering iron tip. A gull wing soldering iron tip is like a standard chisel tip, but it's slightly concave, so like that. So you can put lots of solder in there, and you don't worry about the flux. There'll be loads and loads of flux on the board, and it just worked like a dream. A couple of pins were bridged, but you just use a tiny bit of solder wick and just suck them off. Did you like the sound effect there? Yeah, and that's it. So that's all there is to solder on here, really, of any note. I mean, header pins are header pins, aren't they? They're easy to solder. Now there's two on the top here as well. They're the new A6 and A7 pins that we have on this chip, but unlike the Nano, the A6 and A7 are true GPIO pins. They're not just analog input pins anymore. So you get 2 extra pins there, and these 2 pins here are the extra I2C pins, which is why they're connected to this LCD at the moment. Now this FTDI device, well, it says FTDI, yeah, all right, is connected to the other USART now, the serial port. So you get the standard serial dot whatever, but you also now get a serial 1 dot whatever, a bit like when you run a Mega. Okay, so I'm using that just to prove really that I can read stuff out of that port back to my computer. It wouldn't normally be using this way, I don't think. I think you'd probably use that to connect to other modules via the TX-RX lines. Well, TX1, RX1 now. So yeah, so that's all hooked up for later. Now, I've tested this obviously on that board there, which is that a genuine Arduino? A bit difficult to say. This one's genuine. I've tried it on this one. That was pretty easy. I'll put the chip back in now, but yeah, if it works on this one, then I guess it's going to work, or should work, on them all. And so far I've not found a board that it doesn't work on, because, well, it's just the same chip with a few extra functionalities internally, isn't it, really? Now you can use this board. Let's take that chip out. It gives the wrong impression of what we're actually trying to do, really. It's just to show the size. This can be used on any of these dip type boards, but your board must have a pullable chip. Obviously it can't be used with those clones with the surface mount ones. It just obviously, well, you can't do it. So as long as you've got a dip board, you can put this on, solder the chip on here, a couple of capacitors on the back, and you can play away and experiment. Cool. Oh, what? You haven't got one of these boards. You've only got the surface mount ones. I see. Well, the good news is that from just about everywhere, you can still buy these dip chip boards for about, yeah, I know, the price of a cup of coffee. All right, it's a large cup of coffee, yeah, with added extra whipped cream, yes, and cinnamon on top. But you can buy these boards for about anything between $4 and $7, okay, for say about £3.50 to £5, something along those lines, but you can get them. Obviously, if you want to buy the genuine product, that's going to set you back something like €20 these days. These have come down a little bit in price actually lately, because I think Arduino's keen on selling their other boards, but this is still €20. And when you look at some of these clones, I think this one, yeah, this one's a clone in my left hand. They are very, very similar indeed, aren't they? As you can see, and I guess the people who make this one, and I don't think there's any particular brand on it, probably Geek Create or something. Oh, it's I wonder if this is a genuine. No, it's not a genuine one. No, it's not. I guess they've just taken the circuit, which is freely available, and generated a PCB for it and made sure it looked pretty much like the original. In fact, if you look at the track layout on there, even the tracks are in the same place. Perhaps it isn't original. Well, whatever. You can get these boards, as I say, for that sort of money, and then get one of these. I've got some of these to give away. We'll come on to that a bit later. You need to be able to surface mount that chip though. So if you don't know how to surface mount an SMD chip, this is not the place to try it out. Okay. What I would say is, if you're keen on SMD, a bit like I was at the beginning of the year, get one of those practice boards from Banggood. And the practice boards are either literally just a board that they've made up specifically to practice SMD soldering, and they give you all the components and chips as well and all sorts of things. It's really good. Or it's an old kit that, well, was a kit of something, but they've either discovered there was a big problem with it, or they're just not selling it anymore, and they give you the board and some of the components. You can just play about with that. Cool. Right. Talking about SMD stuff, here's an interesting thing. Yes, now Banggood sent me this. It's a SMD soldering device, tweezers, and I thought, do you know what, this would fit in really well with all the SMD stuff I'm doing at the moment. So thank you, Banggood, for this. It's about $45, so it's not the cheapest thing in the world, but on the other hand, you are effectively getting 2 soldering irons in one. I was looking at some of the Lewis type YouTube videos, and he said that initially he did actually use 2 soldering irons to desolder some components, SMD components, back in the days before he was famous and wealthy, I guess. But this is effectively 2 soldering irons with a sort of a bent tip at the end, and all you do is squeeze this to hold not chips like that, but components, capacitors, resistors, things like that, and you can just put it on and it will desolder a component in no time at all. Now I'll be doing a demo of this, not this video, we've got too much to cover, but I just thought I'd raise it here because I've used this just the other day to repair a USB hub, and I had to desolder a very tightly packed component, and it was just like chalk and cheese. Yes, I know with resistors and capacitors you can just stick your soldering iron on it and put loads of solder on it and hope it comes off, which it usually does, but this is just brilliant. You can also use this, of course, to solder them back on again, as long as you hold the component in place with a little tweezer or something, you know, just on top. Otherwise the surface tension of the solder tends to drag it off again. But this is really, it's one of those things you just think, this is just a marvelous tool. If you're doing SMD stuff, this is great. Very quickly, you've got the temperature gauge here. It tells you what the temperature is up here. You can do it in centigrade or Fahrenheit. Yeah, and that's the rotary control, and on off there. Great. As I say, we'll be covering this in more detail in a future video, but not right now. But I had to just tell you about that because we are, of course, talking about SMD stuff right here. Right, demo time. On the workbench here you can see an LCD display, just about. I know the lighting, the video lighting I've got here just floods this. It makes it quite difficult to see, but you can see that that is counting up. Yeah. So that's running on I2C channel 1, so it's I2C1. As you can see, it's plugged into the top of this little mini PCB here. And the serial FTDI board at the back there, that refuses to stay the right way around because the cable's all twisted, is actually going out of pin, I think is it 11? Can't remember, it doesn't matter. It's the second USART, universal serial port, which I'm going to connect up to CoolTerm rather than anything else because it just makes it so much easier to see. So we'll have a look at the code first while this is running. So let me flip to the code window. There we are. Right, so this is now the code that you're actually seeing running. Okay, so we're including our liquid crystal library, the standard library, although there's something to be said about that. The address of it, fine. Fine. Now I'm defining here, okay, this is me playing about a little bit. The standard serial port is still called serial, but when you're using serial 1, you would tend to use serial 0 as the base one as well. So all I've done is define serial 0 to mean serial, just that makes it a bit easier to see. Well, it does for me anyway. We'll come on to it. So the setup routine, what does that look like? That says, right, serial 1 begin at 9600 baud and serial 0 begin at 9600 bauds. And I'll show you a little demo on that. Ignore that bit at the top. That was from a previous sketch. Oh yes, now I've got a compiler directive here. I'm saying if we are running on a PB type board, then display that line there. And if we are not, display that one there. But I think you can probably guess from the shading there gives it away. The compiler or the IDE already knows that this is defined, and therefore this line is unshaded, whereas the else and that line then end if are sort of greyed out, saying, no, I'm not even going to compile that code. It's not a case of skipping over the code. It's I'm not even going to compile it. It will not be part of the final hex program that goes down. That's the good thing about compiler directives. It actually only compiles the stuff that matches your if condition. So what we're going to do here then is just light up the LCD and switch it on, and then go into the loop, which is a simple little counter. There's an unsigned long. It goes to the home, it prints the value, increases the value. Then we're going to print something up on serial 1, the temporary value, and printf. Where did that come from? More about that in a minute. And that just makes sure that the serial output goes onto a new line when we've reached the end of it. Have a little delay for about a second and go round and round and round the loop. I mean, that's exactly what you're seeing now on the workbench, that thing chuntering up its little value. Now, I have mentioned this before, but I'll mention it again. This looks on video here very, very washed out. I mean, you can barely read it, frankly. In real life, this LCD is a gorgeous deep blue with very defined white writing. I mean, it's a pleasure to look at, whereas this looks awful. And if I was basing a purchase on what you're seeing here, I wouldn't buy one. But take it from me, in real life, these are great. And these are only, these are 16 lines, 16 columns long and 2 rows deep, hence 1602 is what they're generally known as. But you can get 4-line ones as well, which is what I've got in my Benny rain detector system. 4 lines of gorgeous blue with white writing. It's a treat to look at. I'll put a couple of links down below, but you'll find them everywhere. So if you don't like the price, say on AliExpress, go to Banggood and vice versa, but you'll find them in loads of places. And they are pretty cheap, actually. I bought a bulk lot, actually, about, must be 2 years ago, and I'm still using them now and again. Right, so that's just a little by the way, just so you're not wondering why this is such an awful display. Yes, I have got the protective cover on here as well, so I don't scratch it, but that doesn't make any difference to the contrast, believe me. Right, let's fire up CoolTerm then. So we get 2 output windows now, one for serial 1 and one for serial 0, which is the original serial as you'd find on a standard UNO. Right, let's do that next. Right, at the top of the screen you'll see 2 CoolTerm windows, and I mentioned CoolTerm in a previous video. It's a really great program. It just makes debugging all that so much easier rather than using the Arduino built-in one. Although that's good too, believe me, I've used that for a long, long time. But just having these separate windows monitoring various serial ports is great. I'll put a link down below. It's freeware. You can donate if you want, but there's absolutely no pressure on to do that, and it's a full functioning working program. Great. And it's so much better than Putty. Putty I hate with a passion. It just, with Putty, if you've ever used it, you can say, yes, I want to view this port and do not ever close this window. And then Putty says, oh, I can't find that port. Bink, and closes the window on you, and all your settings are lost. Okay, CoolTerm it is. Right, now as you can see on these windows, this one here is on COM25. So that's serial 1, he said, not very confident at all. Anyway, and this one down here, this is on COM9, so that'll be serial 0. Or it's the other way around. So if I press connect on here, so we've got the connect button here. So if I connect both of those, connect, there we are. So that's serial 1 at the top. No, it's not. That's serial 0, the original one, I think. And this one is where we're outputting the actual numbers in the long list, and when it gets to the end it will go onto a new line, like it has done. So you can see that the output is actually coming out on 2 different serial ports. Right, so it's all working. You've seen that it actually does use the extra serial port, and I've shown you that it runs down the extra I2C channel. I'm not going to do any more testing because frankly I don't think we need to do it. I mean, this is a chip produced by Atmel, or Microchip now, wherever it is, and I'm sure that it just works as it always should do. However, the Arduino Ide, which admittedly I'm not using in my code window here, but it's using the same code behind the scenes. The Arduino Ide goes, what's the 328PB? All I know about is an Arduino UNO or Nano or any other of the Arduino boards. I don't know what you mean by a 328PB. What are we going to do about that? Well, For a start, with a 328PB, all your code, every single byte of your code written for an UNO will run on it. Backward compatible totally. Okay, that's the first thing. Secondly, there's a supporting package that gives your Arduino IDE all the functions that the 328PB can do and then some. And that's called MiniCore. MiniCore it is. Now, on the GitHub, there's a MiniCore. There's one you're looking at right now. It's created by a guy called MCU Dude. And the only thing I know about him, and I've been able to find out about him, is that his name is Hans, and he's from Norway, allegedly. I mean, there's bits of information scattered, and that's it. He's obviously some sort of guru in writing, supporting libraries and things, or cores, for various chips. He's done them for all the AVR chips. Perhaps he works for Microchip or Atmel, I don't know. Anyway, he obviously knows his stuff. Now, what is the MiniCore? Well, basically, it's a replacement or an addition to the standard underlying libraries that allow your Arduino compiler and IDE to understand what's going on. So when you write things like digital write, how does your compiler know about that? Well, there's a bit of underlying code that translate that digital write into proper, machine code. And what he's done is replace that with extra bits so that it knows about serial 1 and it knows about print F. Do you remember that right at the beginning of the video? So print formatted. I mean, we should have had that 10 years ago. And I've been using it in my Home Alone project. I don't know if you've seen that, because I tend to try and use the standard C++ stuff. But the fact it's built in now to the Arduino IDE. Yeah, if you've read my blog on this entire subject, you'll know that I'm somewhat irritated by Arduino missing the boat on this. They're never going to produce an Arduino V4 now, even though I've called this an Arduino UNO Plus. The time has gone. They should have done that back in 2015, 2016 when that chip came out. They're never going to do it now. They're moving on to, SMD chips and other 32-bit chips, not Arduino UNO Pluses or V4s or whatever you're going to call them. But they should have done and could have done so easily. And we'd all now be using the 328PB and with the extra facilities it gives us. And of course, you don't need them in every single sketch. Of course we don't. If you don't use I2C, you don't use it. But if you do use it once and you find there's an issue, you can use another channel and everything sorts itself out. Now, this is quite a long README, and it tells you all the things that it supports, all the supported microcontrollers and everything. So it's not just 328s, Ps, PBs, whatever. It tells you everything. Now, the other thing it gives you, as you've just seen there, all the clock frequencies that you need for writing bootloaders into your chip are all supported here. So I'm actually running at the moment on a crystal, so 16 megahertz crystal, exactly the same as your standard chip would. But you can go down to 1 megahertz or 8 megahertz, which is what I use an awful lot of battery powered stuff. Yeah, all that is supported, and it's worth a read, and it's a nice read too. And yeah, it tells you all about the options. So when you select an option in the Arduino IDE, it says, well, what board have you got first? And you say, well, I've got a MiniCore. And it goes, yeah, MiniCore what? And you go, well, a 328. And it goes, which flavor? Have you got a P, PB, what? And you can set, you want to see it. All right, let's have a look at that first. Right, this is the standard Arduino IDE now, where I've installed all that MiniCore. As well as the other IDE that I was using, Eclipse. Okay. Now, if you go to Tools, you'll see this drop-down window, and there's the Boards Manager. Now, I've said I've got an ATMega328. Now, that is found in, if I can scroll down quickly enough, there we are. Now, you see the heading there says MiniCore, and you've got all these different options. ATMega8, look at that, that's going back a few years, isn't it? That's what the UNO used to have, Anyway, ATMega328, I've said, and it goes, okay, what sort of clock do you want? And you can see all these different clocks you can have. You can even run it at the maximum of 20 megahertz, but your millis and stuff might be out then. I don't know if he's compensated for that. Anyway, I've said 16 megahertz crystal because that's what I've got. Brownout has been disabled. I've disabled the link time optimization as well, just for this demo. What variants have I got? Well, I have got a PB, not a 328A or PA or anything else, or P, which is the standard one, of course. 328PB. Do I want a bootloader? And I said, yes, I do, because on the standard UART, not the second one, because you can put it via the second one if you want to. on my port, whichever one it is, and that was it. And then I said, I'm done. But the bigger question, I suppose, for you guys is okay, so I take that PCB or make one, put the chip on it, put my headers in, then what? How do I get the bootloader? Yeah, I'm in the Arduino Ide, but how do I get that bootloader into that chip? Good question. Here's how you do it. Right, to get the bootloader onto your Arduino chip, you need another Arduino, which is what I've got under here. That's what that is. But I've got this shield on, which we've spoken about in the past. This is the OpenSmart one, but there are other ones not called OpenSmart, but they're effectively identical. It's just a shield that makes things easier. You can use all the wires from the base Arduino if you want. It's just messy and prone to error. This makes it error-free. So all you do normally then, if you have an Arduino chip, you just drop the chip into this 0 insertion force socket, close it down, and connect this end to your computer, and you go, burn me a bootloader on there, please, and beep, beep, off it goes. I've demoed this before, I'm not going to do it again now, and that's it, you've got your bootloader on here. However, we haven't got one of these chips anymore, have we? Because we've taken these out, but cunningly, of course, I've created it so that this contains header pins, and yes, it might have the chip on the end of it. We don't care about that. I've made sure that it fits on here. So we just drop that in there with the header pins, close it up, and burn the bootloader on this one, which will be the surface mount version. Exactly the same. There's no funny business going on here. It's exactly the same. Okay, so that's how I did it. The thing is this, I think we had this in that video where everything was the price of a cup of coffee, and I think this one was actually. And you buy this once and you've got it for life, and it just makes life so much easier. You know, you do it once on the Arduino with cables running to Mozzie and Miso and all that, and then 3 months later you want to burn another bootloader and you have absolutely no idea how to do it anymore. You have to go back. With this though, I just leave these two permanently connected together, because after all, that Arduino at the bottom is the price of a cup of coffee, the same as that on the top. So the two together, that is my, well, serial bootloader uploader. The code that you put onto the base Arduino here is called the Arduino ISP. It's in the examples folder, so it's a no-brainer really, and I've been through all that before, and it's something that you really need to think about if you're going to start burning bootload, because bootloaders to your chips you know, more than once every year. So as I say, this then drops into there with the headers, gets programmed just the same, and even if you use a different version like this, now you can see this one has actually got stackable headers on it, but it's still got the same surface mount chip on here. Oh, they're not perfectly aligned, are they? Look at that. Anyway, these are stackable headers. They just drop into that that one there just the same, and it all works fine. Now, stackable headers versus that one at the back there with pin headers, what's the difference? Well, I only did this one to experiment really, just so that you got something to plug into the top if you wanted to. I haven't had a need to do that yet, and I didn't solder those I2C and extra A6, A7 pins down there either, because I just wanted to see how easy it was to do. And it wasn't that easy, because we need a 14 pin run here, don't we? Now, you used to be able to get 14 pin stackable headers when the old Teensy was around. Unfortunately, the Teensy's moved on a bit now. Nobody's making 14 pin headers, not unless you're willing to buy 1,000 of them. So what I had to do is get an 8 and a 6, and then you have to file down, sand down the ends, because they won't fit in, because you've got the bit of plastic in the way. And as you can see on that one there, I've probably filed that one a bit too much, but it's okay. And that one's probably a better fit, but it's a bit wonky. Not that that makes the slightest bit of difference to its performance, just me being OCD-ish. Right, so that also works. And there's one other advantage, I suppose. The stackable headers, these pins, are flatter and thinner than the standard header pins of the sort that's on this one. Okay, those pins on there are squarer. They do fit the IC socket, but it's a bit of a push, and I wouldn't want to keep taking it in and out of there. But these are so thin, these are more like IC pins, and they do go in easier to that chip. So yeah, that's all I can say about that really. But you do need something like this to burn the bootloader. Oh, and you can of course then burn your initial program to it if you want to as well. But you might, once you've got the bootloader on here, you can put it into your board and then use this like a standard Uno. No different at all. Serial input here, load up your program, Bob's your uncle. Now, if you thought this was fairly small, I was hoping initially not to use this chip. That's the, I think it's the low profile quad flat pack. I was going to use one of these, which is so small. This one here. Now this is the very small quad flat pack. It's probably got a different name. I'll put it on screen if it's different. And but soldering it could be a bit of a challenge, because if I turn it over, you can see that the soldering is all underneath, so there's no pins. And I thought, I don't think I'm going to be able to do that, which is a shame, because this board is obviously longer than the chip. The chip only goes up to where my thumb is, and that the chip then hangs over the edge. But with this tiny little chip, the chances are we could place it between the pins like that and still manage to route all the tracks around. But that was a step too far. Maybe that's something for the assembly process of JLC PCB to do for me one day. But frankly, this works well. And there's one final option that you can use if you're willing to spend the money. Microchip themselves sell this, which is an ATMega328PB X Mini PC. I don't know what they call that. It's just a development board, and it looks like this. There's your 328PB in the middle. I don't know what all this is. That's probably the USB interface. I don't know. I haven't really looked at this. I saw it and I thought, oh, perhaps I'll get that to experiment with. But frankly, I've not really found a use for it yet, because having got my little PCB running, I can now use the Uno board just the same, can't I? Okay, special offer time. I made, or had made, I should say, 25 of these boards. So obviously I've got a few to give away. If you want one and you're capable of soldering that 328PB chip on there, so first of all you've got to source one of those chips, and secondly you've got to be capable of soldering it on there, which if I can do, anybody with a modicum of experience will be able to do, believe me. A couple of capacitors on the back. I would not advise leaving those capacitors off. They're only 100 nanofarad, but you do need them physically close to the chip, which is why I've made an allowance for them. The design of this board will also be available on my GitHub, so you can either download it all into Easy Ide and produce your own. They're pretty cheap, let's face it. If you just want 5 of these, you can go to JLC PCB and order them for, what is it, $5 or something? I can't remember the price now, but it's cheap. Okay, or you can get one from me if you're interested, and send me your details. My email is in the About tab of my channel. Yes, you have to be on a PC or Mac to find it, otherwise it doesn't show. So you go to the About tab, you go to the Business Contact button, you press it, and then the email address is shown. Okay, and why am I being so obtuse about this? Well, the fact of the matter is I get about 4 million bits of spam a day, as you can imagine, and me giving out my email address like this in a video, I'd get about 55 million bits of spam a day, so I'm trying to cut it down. That's the only reason I'm being funny about it, really. So if you want one of these and think, yeah, I could easily make one of those, and that means I can experiment then with all the PB features on a standard Uno, send me your details, right? You don't have to send me your address first time if you don't want to. If you just want to make a contact, make sure I can get back to you, then you can send me your address details later if you like, or just send them with the email in the first shot. And I'll just pick out the first, I don't know, 20 people or so out of the hat and give them away. And of course, if only 2 of you respond, then you'll definitely get one, won't you? Right, I think that's probably about it. I know we've zoomed a bit ahead of ourselves on this a little bit, but basically at the end of the day, all we're doing is pulling the chip on the standard Uno. Well, all right, that's not a standard Uno. Let's find a standard Uno to do it with. Here we are. This is an absolute 100% genuine Arduino Uno. Right, all we're doing is pulling the chip, soldering the PB version of the chip onto here, plugging that in there with standard pin headers. Once we've put the bootloader on here via something like this, or if you really want to be a masochist and do it via the underlying Arduino, with your Mozzie and Miso and S-Clock and all the rest of the cables you need as a one-off, fine, do that way. But once you've got the bootloader on here, then you can plug it in here, and this board will act as a standard Arduino Uno, but it will have some extra facilities if you install the MiniCore. And the MiniCore is self-explanatory. You just read it. It's been wonderfully written. I wish I could contact Hans, really. He's well thought of in the Arduino forums, that's for sure. Okay, that's it then. So we've done the PB version. We've got the PCB from JLC PCB. Thanks very much, JLC PCB, for doing this. It's great, those little boards, exactly to specification. Even the little tiny corner chamfer that you might not even be able to make out on here, that I took off because I didn't want it interfering with those capacitors. See, those capacitors are quite close, and I thought, oh, I've got to make it really tight so it goes in there. Yeah, I do think of these things, you know. Anyway, we've done all that. We've talked about MiniCore, we've talked about bootloaders, we're talking about how to load up the bootloader. I think we're done. Give me a thumbs up if you like the video, and it tells YouTube that this was a worthwhile video. And thanks for watching. Look forward to your comments down below. See you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.